Welcome back to Physics 101. Today, we will be discussing Chapter 11 on elasticity. So in our first question, we have a metal rod that is 4 meters long and 0.50 cm in cross-sectional area. The question states that the rod can stretch up to 20 cm under a tension of 5,000 newtons. We are asked to find what is the Young's modulus for this metal rod. The most efficient way to solve any kind of problem is to first analyze the question and see what formula we can apply. In this case, the Young modulus formula. We know that the Young modulus formula is stress over strain. We can also say it like pressure over change in length of metal rod divided by its initial length. Now we have the formula all set. Let's now focus on our variable. We know that when dealing with formulas, we must have the right units in our variables. Here in our first question, we are given an area of 0.50 cm squared, but we need it to be set in meters so that we can plug it in to our formula. We would need to convert this value. We know that 1 cm is equals to 0.1 meter, but let's not forget the quantity square because we are converting cm squared. After converting, we'll get an answer of 0.5 times 10 raised to negative 4 meters square. Now, for the final step, let's plug in all our variables to arrive at our answer. We have the 4 meter long rod times the 5,000 newtons acting on it over our area times the change in its length, which is 0.2 times 10 raised to a negative 2 meters. As you can see, all our units variable are in meters aside from our force. It means that we are heading in the right direction. As a result, our Young modulus would be equal to 2 times 10 raised to the 11th Pascal. And there you have it, our final answer. Now let's proceed to our question number 2. Now, for our second question, we are again asked to find the value of the Young modulus, but this time, we are given a different area that we need to find as well as the force acting on the nylon rope, which is 45 meter long with a diameter of 7 millimeter that elongates 1.10 meter under the mountaineer's weight of 65 kilograms. Just like what we did last question, we first have to convert our variables to have the correct units. In this case, we first need to convert the 7 millimeter into meter. We know that 1 millimeter is equals to 1 times 10 raised to the negative 3. Now, we'll just have to plug it in into our formula, pi r square, because it is the area of a circle, which is the area of the cross-section of a nylon rope. Don't forget to divide the value we got to 2 after we're done converting, because we are given the diameter, but we need the radius. We will arrive to the answer of 3.85 times 10 raised to the negative 5 meter square. Now we are done with the area. Let's solve for the force. Solving for the force would be easy since we know that the force applied to the rope is the weight of the mountaineer. We would just have to times the mountaineer's weight to the gravity, which is 9.8 meter per second square. The value of our force would be 637 newtons. We have already solved for all the missing variables we need for our formula. Let's now plug in all the values to our Young modulus formula, and we would arrive at a final answer, which is 6.77 times 10 raised to the 8th Pascal. Our third question is rather simple, but it teaches us how to manipulate our variables to come up with an answer. Problems like this help us to think more creatively in approaching different kinds of problems we encounter. Here, a brass wire is to withstand a tensile force of 350 newtons without breaking. What is the minimum diameter must the wire have? By looking at our book, the University Physics, it states that the breaking stress of brass is 4.7 times 10 to the 8 Pascal. We know that stress is equals to the force per square inch, which is force over the area. And the cross-sectional area is the area of such a cut. It doesn't have to be a circle. Here, the formula of our area is pi r square. But what we need is to find the diameter. Now here's the fun part. We know that 2 radius is equals to the diameter, which means that we could rewrite r as d over 2. Plugging it in our formula, pi r square, we would get an area of d squared pi over 4. Now, all we have to do is to isolate d to get the value of 9.7373 times 10 raised to the negative 4 meter, which is equivalent to 0.974 millimeter. Now that's the end of our physics class. Thank you so much for listening. Hope I was able to help your physics journey. Tune in for more physics solving fun.